Comet tails indicate which way they are headed. So, ever wondered what comets are all about? So, if not, so let me break it down for you in very simple terms. I want you to imagine this. So, cosmics are basically big chunks of dirty ice floating around in space. That's it. So now, when these things get closer to the sun, these dirty ice blocks start to heat up, and they begin swaying out gas and dust and all. So now on Earth, if something's moving and there's wind, you'd expect a trail behind it, right? So like when you see a shooting star, something like when you see a shooting star. So the twist is that in space there's no air, right? So comets don't leave a traditional tail. They are shaped and pushed around by sun's radiation and solar winds, always pointing away from the sun. So this is not it. So let me tell you the fancy stuff of it. The sun's high energy ultraviolet light crashes into the comet gases, and it's like this cosmic strip show. Electrons getting stripped away, forming charged ions and all. You know this stuff, all the science stuff. So these ions then follow the magnetic field lines and shoot out in the cold blue ion tail, kind of like comet signature, right? Yeah, you have seen it in images. At the same time, the comet is shedding some dust, like it's having a celestial spring cleaning kind of thing. So sunlight then creates this high intense pressure bubbles that pushes against the dust, guiding it into this wide streak that curves along the comet speedy orbit, I can say. So if I have to put it together in a nutshell, I would put it like this. Comets are like this space snowball with a tail that always points away from the sun, not towards the sun but away from the sun. And when they get close, they are like pointing on a light and dust show for the whole universe. So isn't it just space? So isn't this theory is a bit fascinating for all the all the cosmic lovers out there, that comet tails not always indicate where they headed. Instead, they are just the dust and the trails which points away from the sun. Thank you. So we are talking about that light isn't affected by gravity. So we have not discussed this. So you know how gravity pull things together, right? We all know that, we have been studying it ever since fifth standard. So like when you drop your favorite snack and it falls straight to the ground, it turns out that gravity thing is a bit more complicated than just your favorite snack falling onto the ground. It's way more complicated. Now, a long time ago, a smart guy named Sir Isaac Newton, came up with the idea that gravity is like this invisible force that pull things with mass towards each other. So fast forward a bit, and another genius, Sir Albert Einstein, came along and said, "Hold on a second, Isaac Newton. It's not just about mass pulling thing. So it's about the shape of the whole universe. So think of this universe like a giant rubber sheet, like a really big giant rubber sheet. You put a heavy ball on it, a very heavy ball, and then bam, the sheet stretches as soon as it falls down it, creating a dip in that giant rubber sheet. Now roll a smaller ball on that sheet. Instead of going straight, it's going to curve because of the dip. So that's what stars and planets do the space time. Now, light is supposed to be this super speedy thing, like the speed of sound and light. These are very fast things. So, speed of light, it's really fast, travels really fast. So usually, it's not bothered by these dips in this space time, as we talked about. This giant rubber sheet shouldn't be affected by it. But this is where the things get really interesting. Black holes are like the ultimate troublemakers for the lights. They create these crazy curves in space time that just keep bending and bending and bending over the time, and even towards the infinity. They keep bending. And you know what? Not even light can escape these bends from this black hole. It's like this. How do you put it? It's like this cosmic roadblock that not even the fastest things in this universe can get past this. So there you have it, gravity, rubber sheets, and black holes. Who knew the universe could be so wacky about these things? And yes, so as we're talking about why light isn't affected by gravity, so this was the reason about black hole, that how black hole captures this light and nothing gets past it. So we have debunked another theory why light isn't affected by gravity instead of Earth being such a being such like a giant rubber sheet. So you won't believe how much rock is hanging out in the neck of a solar system, right between Mars and Jupiter. And it is known as the asteroid belt. And it's basically a cosmic rock party. We are talking about around 3000 minor planets, and you can say a whopping 7 lakh something 7 lakh 50,000 asteroids, some of which are way bigger than a sky high building. Now you might have heard this wild idea that cruising through this asteroid belt is like playing some space game, or any space game which you might be interested in, and you can't blame it on yourself. Instead, you can blame it on these science fiction films like Star Wars, where Han Solo gets all this daring in this Millennium Falcon. C3PO chimes in and saying the chances of survival are like 3,000, 4,000 to 1. But let me tell you, if our asteroid belt is anything like the one around Hot, then he has totally missed the mark. Because back in the 70s, 80s, NASA's Pioneer 10 went where no spacecraft had gone before, right through the asteroid belt. So I want a bit of your imagination here of how you of how you take things. So picture this. This asteroid belt, this has a thin layer of aluminium honeycomb for protection. So no bumps, no bruises, nothing. Why? Not because it was dodging asteroids like a professional spacecraft or anything, but because those space rocks are seriously spread out, like way too apart from each other. I mean, we're not talking about a few kilometers, but we're talking about an area of 140 million miles across. Yes, 140 million miles across. The average distance between the asteroid is around maybe 6 lakh miles something. To put it in perspective, that's more than the double the distance of Earth to the moon. The distance between Earth to the moon into two. So much for a crowded place drama turns out. The asteroid belt is more like a cosmic ghost town, you can say, which has ample of space for anyone. So the real deal is that it's not that big asteroids you have to worry about. No, not at all. It's those tiny dust troublemakers in that asteroid belt that show up when asteroids have a little bit of collision randomness, like when they collide and burst into small pieces of rocks. For perspective, they are small, but they are also big. Those minute grains could mess up with your spacecraft for sure if you are traveling in space. But being real, avoiding rocks the size of a grain of sand isn't exactly the edge of your seat television entertainment. So the myth about this is has been debunked, which is that the asteroid belts are so close in distance. They are not. They are miles apart. Ever since you were a kid, or back when you have heard that the Great Wall of China can be seen from space. So now we are diving into the fascinating world of the Great Wall of China. So, as I've said earlier, you have probably heard that it's the longest thing humans have ever built, stretching to across a mind-boggling 13 to 14 miles. Sorry, 13,000 to 14,000 miles. So, if I have to put it into perspective, that's like traveling across the country a bunch of times, quite a number of times. So now some say that you can see it from the space, and that's the idea been hanging around probably since the 1930s. But did it ever occur to your mind? Have you ever seen any pictures that is it true or is it not. I mean, you just heard things and you've made a perspective that whether it's true or not. So no doubt that the Great Wall of China is crazy long and it's not wide at all. Just a bit over 20 feet at its base. So picture a really tall giraffe lying down. That's about the width. And this and the important thing is that it's built from a stuff that kind of blends in with the land around it. So smart move, right? So when you are zipping around in a low earth orbit, if you are in space, so about around 99 or 100 miles up, you won't spot it without the help of some high technology, without the help of any high tech. So it's a bit of double standards for people to say that can be seen from space. So, but Commander Chris Hadfield, who hung out in the International Space Station in 2013, if I'm not wrong, set the record straight. He went on to tweet that I did not see the Great Wall of China from space, and neither did the Chinese astronaut. With a camera, big enough lens, and a clean air, maybe. So there it is. There you have it. The Great Wall of China is a beast on the ground, but the reality is that you won't catch a glimpse of it with just your eyes from space. You until you have some crazy big telescope that can really zoom in and would be helpful for you to actually capture the beauty of Great Wall of China from the space. But for what I believe is that Great Wall of China is one of the wonders of the world, and its real beauty lies in if you actually go down to China and stand on the Great Wall of China and witness its greatness. Thank you.